are we doing play?
This is really fun to watch because I didn't struggle.
I just reply.
But I did struggle.
Did you apply just reply?
Yeah, but I did it all in
Okay, so what we're gonna do is we already talked about how to use Taylor. Sometimes we will ask on AP exam they will ask you says find third degree polynomial represents something like represents sine of x. So you just stop at the third degree. Does that make sense? You don't keep on going. If I ask you to find power series, then you keep on going. Now, if I say ask you find third degrees of something, then you start at x. You stop at x to the third. Okay. Now, sometimes they can have a center that is not 0. So, for example, center of pi over 4 or pi over 6, you can get that. The only thing difference is that's between Taylor and Maclaurin. Okay, so we're gonna go through that, and we're gonna talk about what kind of error would you have if you can use that to approximate something. So we're gonna go through that. So we're gonna go through one of the questions here, and they say find the Maclaurin series of something. That says if you says find the Maclaurin series at P6. What does that mean P6 is, right? So, but you guys probably already know this.
We can't see anything.
You can't see anything? Okay, my bad. Let me share my screen.
Is Warburg gonna be there like awkwardly staring at us?
Yeah.
You know, it's 2 months.
Yeah, isn't that crazy?
Gabby, is Warburg gonna be there like awkwardly staring at us?
I hope so.
10 months away. Oh, I hope so.
That'd be kind of funny.
We take a picture of it.
Like, are they actually gonna make tent for the courtyard?
Connor,
How are you asking me?
Well,
You thought you were an FDA.
No,
no, they call it down in the
for Titan TV.
yeah.
Oh,
If you get a picture
There's
with
supposed to
Warburg,
be a tent. That's what I've been told.
there's gonna be a tent.
Yeah, like a wedding.
Like, how?
Dude, that's for the whole budget. Probably
why?
can't.
It's gonna be like hot as balls tonight.
Yeah, it's gonna be very muggy.
So Connor, if you can get a picture with Warburg, I will pay you for this.
The high tonight is at 5 o'clock. What the hell? It's gonna be over 80 degrees at 7.
It'll be worse than
Lucky you. You guys saying 80-degree weather.
I'm not going to that.
Finish your damn word. Well,
Okay, so in the terms that we can find a Maclaurin polynomial for cosine of x. So let's just say if I have f of x, and that just says is equal to cosine of x, right? And the question will probably ask you says, hey, can you find the 6th degree Maclaurin? So find the 6th degree Maclaurin polynomial. I have no idea how to spell Maclaurin. So A-U-R-I-N polynomial. And approximate. That's a cosine of 0.1. And if we remember the power series, right? I mean, you can go through Taylor series to find it, but if you memorize it, you know that it's all the even numbers. Do you remember that?
Yeah.
Which is, in this case, P6 of x. If you do the Taylor series, it's going to give you, let's say it's 1 minus 1 over 2 x to the square plus 1 over 4 x to the 4th plus minus 1 over 6 x to the 6th. And this is the 6th degree Maclaurin polynomial. Yeah, but it's a 6th degree. It's all the way to the p to the 6th because there's some things that's in the middle that it doesn't show up. So for example, x to the 1st, x to the 3rd, and x to the 5th, that doesn't show up. But this is the 6th degree.
So it's not n equals 6, it's the p that you.
Yeah. Well, it depends on how the word they want it. They can say to find the third Taylor polynomial, which is the third term.
Yeah.
Now, if it's a p to the 6, it's the 6 degrees.
What is this unit called, or just the end of what is this?
This is the end of the Taylor polynomial approximations. So if I want to find out what the cosine of 0.1, then what you're going to do is you just type in, let's say 0.1. And you're going to do 1 minus 2 factorial of 0.1 squared plus 1 over 4 factorial of 0.1 to the fourth minus 1 over 6 factorial of 0.1 to the sixth. And this is going to be the approximations. You'll roughly get this value if you use calculator, so 0.995004165. And this is actually very accurate. If you go into typing cosine of 0.1, it's going to be very close to this value.
And the amount of terms of, it's the more terms you add to that, the more accurate it's going to be.
Yeah, just like the graph, the more term you add to that, the more look like a sine of x graph, right? Or cosine of x graph. So the more the term the more the degree, the better. Now, last time we already talk about the error bounded. We're gonna apply to this case, but here we're gonna talk about one more things. Sometimes we can ask you says this is what on AP exam they're gonna ask you says, evaluate p to the 6, and they will say it's approximate 0.1, and all you gotta do is do p to the 6, and then which is the 6 degrees. And then you're going to plug in 0.1, and you're going to get using calculator and just get this evaluation. And that's the approximation. Am I going too fast? No. Okay. So can they say different things on AP exam? They can also say different things. So I'm just kind of go over like what kind of question they will ask you on FRQ. This is the one style they will ask. They will ask you says find the 6 degree or find the fourth terms Maclaurin polynomial or the 6 degree. They can either ask the one way or the other way. So they will ask you either 6 degrees or the fourth term. The fourth term is going to be this. This is going to be Maclaurin series for the cosine in fourth term. This is the approximation at 0.1. Now, can I says another way that they can ask you is on AP exam, they're gonna say find the third term of Taylor series. Now, what does it mean by Taylor series? Taylor polynomial of f of x equal to sine of x. Expand about c equal to pi over 6. Now, that just means center at pi over 6. That's it. Okay? So normally, you will have to show the AP exam says you take fourth derivative, right? So you're going to say it's f of x equal to sine of x. Although even I already know power series, but I will have to show AP exam like this. You have to show them that you take multiple derivative, cosine of x, f double prime of x equal to negative sine of x, just like what we did on yesterday's homework or 2 days ago's homework. That's equal to negative cosine of x. And we say, hey, let's plug in pi over 6. Because now your center is at pi over 6. So what happened? Instead of plugging 0 before, now you're going to plug in pi over 6. What is sine of pi over 6?
That's a great question.
Sine of pi over 6.
1 over 2, good. What is f of prime of pi over 6? Which is cosine of pi over 6. Yeah. F double prime of pi over 6, which is negative sine of pi over 6, which is negative half. And f triple prime of pi over 6 is equal to negative cosine of pi over 6, which is negative square root derivative. So if you want to find the third degree polynomial, then you're gonna say, okay, well, let's plug in the power series. The Taylor series. What is Taylor series gonna say? It's gonna be, in this case, P3 of x is gonna be f to the pi over 6. Does that make sense? Instead of f of 0, now it centers at pi over 6. Plus f prime of pi over 6 times what? No. No. What's a Taylor series? X minus pi over 6. Thank you. Plus f double prime of pi over 6 of x minus pi over 6 to the second.
With that speed.
Oh, right.
And over, hold on, over something. I'm missing something here. Over 2 factorial, right? This is over 1 factorial, right? And then go into the next one. So plus f to the 3 of pi over 6 over 3 factorial times x minus pi over 6. So that's how you write out. If you write out like this, you're going to get some type of credit. If you write out more, they will give you more credit. So what's f pi over 6? We already know that. That's equal to 1/2 plus square root 3 over 2 times x minus pi over 6. Am I going too fast? Minus 1 over 2. And then what is pi over, f prime pi over 6? It's going to be square root. F double prime is negative 1/2. Sorry. Negative 1/2 is already there. So 1 over 2 times 2 factorial. And x minus pi over 6 to the square. And then minus f triple prime, f triple prime pi over 6 is what? Square root 3 over 2 times 3 factorial times x minus pi over 6 to the third. So this is the third term. Now a little bit unlike the Maclaurin series is going to be centered at 0. So something's going to go away. But this case, that center is not at 0. It's actually there's some term here for sine of x. That there's some term there. And you had to evaluate. Am I going too fast?
We're vibing.
Okay. Vibing.
Yeah.
What does that mean?
Big chiller.
Surviving.
We're tired and we're just
Vibing.
we're big chiller.
Okay, so this is how do you face what AP exam want. AP exam is gonna say it's, find the 6-degree Maclaurin polynomial to approximate something. Then first we'll find out what a 6 degree is and then plug in. Can they have a center at off center, not at 0? Yes, they can be at pi over 6. Then you're gonna do the same thing. It's just Taylor series. It's just not x minus pi over 6, and all the term there is gonna be including, because you no longer evaluate f of 0. F of 0 is gonna cause. I think this term is gonna go away. F double prime of 0. F double prime of 0, that's gonna be go away. So Taylor series has extra terms you have to take account for. Am I going too fast? It's good? Okay. Now we're gonna talk about the error bounded. And this one's kind of confusing. So I'm trying my best to do this. So this is also called Lagrange form of the remainder. So
Lagrange is a famous guy.
Yeah, really.
yeah, he's the person invent mean value theorem. He's not rules. Rules says derivative must equal to 0. must have the horizontal tangent between A and B if f of A equal to f of B. Now Lagrange says, hey, kind of tilt his head a little bit, says f of A does not happen to be equal to f of B. So it must have a slope is equal, secant is equal to the tangent. And that's what Lagrange did. And so Lagrange is a very well famous mathematician. So there's
Anyone who may do math.
pretty much you can do. I don't know if you guys see the problem with 3x plus 1. It's by Batavian. He was there was simple math problem no one can solve.
Oh, where it's like if it's an odd number, you do one thing, and it's an even, you do the other thing.
Yeah, and then you do 3x plus 1, so you times 3 plus 1, and then you do the same thing. You keep on going over. But there's a pattern, but nobody, even the greatest
Oh, yeah,
mathematician.
no, it always goes down to 4, 2, 1.
Yeah.
That's the pattern.
Yeah. You saw that video?
I think I've seen the video.
The one she saw the thumbnail for it. I didn't. Come back.
Yeah, it's a very interesting, and there was a lot of people still cannot solve the problem. It was a really easy problem, but no one knows how to do it. So they say like they only discovered math at the very beginning stage of math. So Lagrange form of the remainder.
I spell his name.
Lagrange. So basically, we're gonna establish this f of x, and we're gonna say f of x is gonna be exact value is equal to Pn of x. Well, that's just the one that we just did. We can approximate a value. Approximate a value, right? And then plus, of course, there's a remainder. So this is a remainder. Question about this part. So we sum up to be saying this. Error, which is we're going to call it r to the n of x, is equal to the f of x minus the Pn of x. Now remember last time when we're doing this type of situation, since that you know that, so for example, if I plug in 1 here, right, the first term approximation is gonna be not very accurate. As I'm starting adding more term, I become more accurate. Does that make sense? If I add this term, so if I add 3 term, it's gonna be more accurate just the 2 term. So the 4 term is gonna be more accurate than 3rd term. But then if you subtract them, right? If you subtract them, then you're gonna see what happened. This the small error that is gonna be a plus minus. I forgot what's it called. What's a plus minus called?
Plus minus.
No.
Value.
No, what is there's something called it. I don't know what they called it. I forgot. Anyway, don't worry about it.
Never heard it called.
So this term, right? So this term, I would say this term is always smaller than this term, right?
Yeah.
So what we're gonna do is, if we get to this value, we approximate to the 4th term, we want to say, well, what is the error? The error is gonna occur in the next term. Does that make sense? Like the last time, if you did your test correctly, it was n plus 1. We worry about the next term because next term is going to be smaller. If it's smaller, that's going to be the error that has a plus minus. Does that make sense? Okay, so let's go to the next term. So the remainder, so we figure out what the remainder is. Remainder is the next term, which is f of m plus 1 of some type of z over m plus 1 factorial times x minus c to the m plus 1. Let's assume that's Taylor series. This is going to be the remainder. This is called the remainder of Taylor series.
Mr. Ye, what's the part next to the F to the M plus 1?
F to the m plus 1 to the z. So I plug in z to the m plus 1 factorial over m plus 1 factorial.
Is it Z or C?
Z.
Why?
Z just another value. Okay, remainder of the Taylor series.
Is it so? It's x minus c to the n plus c power, right?
Mhm.
Could you zoom in on that, please?
And it's supposed to be.
Could you zoom in a little more, please?
You're really blind, aren't
A
you?
little bit like towards the top. I need some of the upper stuff. I'm not blind. I'm just me, you know.
What do you mean?
Well, it looks like Ukraine's gonna become a puppet state of Russia.
Did we have a senior walkthrough?
Is that already done? Are we finished conquering?
Is that the senior?
I mean, it's not looking good for Ukraine. They're already at the capital.
Walk-in was.
They're at the capital already?
What do you think? When do you think that they're gonna stop? I think Russia can just keep on invading Europe too. If we...
Well, what do you mean?
I think once they get to Poland, they put a NATO state and like NATO.
No, once they do. What do you mean? We put sanctions on them.
Yeah, but they also cannot fight them.
Either gonna go to war unless Russia stops. I know.
Unless the rest of the world just stops dealing with Russia, the sanctions aren't.
But Russia has also had nuclear weapon though, so it's pretty much we're gonna nuke
They're
each
the
other.
only country that's close to us when it comes to nuclear weapons. And they're not
ahead of us.
They're ahead of us.
They have more weapons than we.
Really? I thought
That-
They have like giraffes.
Yeah.
Well, I mean, when you combine the full power of NATO.
They have giraffes in Russia.
Yeah, I'm saying at this point. I have no idea what I'm talking about.
Canada's in France. You know, not NATO. North American trade.
It's North America is a treaty organization.
Okay, so let me finish talk about this problem. We can talk about politics. So we're gonna give you a questions, and we're gonna determine the accuracy of an approximation. So that just say if I have the
Wait, no, you scroll down. You scroll below. Yeah.
okay, so
You can still see the board. What do you?
using Taylor series, we're gonna use
What was that?
so use Taylor theorem to approximate sine of 0.1. By using p to the 3 of x, which is the third degree. And we're gonna determine what's the accuracy. Okay, we're also gonna determine the accuracy. We're gonna determine the accuracy.
What is that weird symbol in the box?
Z. Oh, wait, what?
In the numerator, on the right side of the numerator.
N plus C.
X.
No, in the numerator. that's
Oh,
a-
Z.
Z.
By the way, that's the n plus 1, sorry. That's n plus 1.
Oh, okay.
Yeah, it's confused by n with x and
n plus 1 there. Okay, so do you know what's the third term of Maclaurin polynomial for sine of x?
negative sign of x.
No.
No, isn't it x to the 7 over 7 factorial?
Yeah.
No, the third degree, sorry.
Oh, and
X to the 3rd over 3 factorial?
Yeah, but there's also the first term is
X
x.
minus x to the 3rd over 3.
There you go. So can I approximate at 0.1?
I mean, yeah, for sure, dude.
Just plug in 0.1, so it'll be 0.1 minus 0.1 to the third
In this case,
over 3 factorial.
Wouldn't you be supposed to use Taylor series since it says use Taylor theorem?
Maclaurin is Taylor's, which is for
Yeah, right now we have
Oh, okay.
approximate sine of 0.1, so we're gonna use center at 0 because that's the most closest thing that we can come up with. So we're gonna use 0.1.
Alright.
So if you do this correctly, you will end up to be 0.099833. 0.99833, sorry.
0.09983.
Yeah, 0.099833. That's the approximation. And then if you want to find out what is the next thing is, so we're gonna say we're gonna go into plug in the next term. So what the next term will be, so we're gonna say that's gonna be sine of z over 4 factorial to the 0.1 to the 4th power.
Use the root of the x3.
What'd you say? Because we plug in the n plus 1 factorial, right?
What exactly is the z?
That's a great question. So at this point, we're gonna say, well, we're not gonna be able to find the exact value of z. You should not expect to be able to find the exact value of z, but just work out sine of z times this is 0.1 to the 4th over 4 factorial.
How do you do 0.1 factorial? What does that even mean?
There is no,
No,
0.1
0.1 to the
factorial.
fourth.
0.1 to the 4th.
That's a good point. Wait.
Is less than 0.001 to the 4 factorial.
Listen, I'm begging you to zoom in, man.
We don't know what z is. We don't care about what z is right now, but we just know because z is going to cause something much smaller, right? So at here, it's going to be less than 0.01 to the 4 factorial. So that's also known as what? Roughly is equal to 0.000004, I think 504. If you type in a calculator, it's going to be 0.000004.
Should we put the correct number of zeros on the top? No, we're saying that it's less than. Kind of is always less than. Saying that.
Is there before 0?
Oh.
It's a 0.00. There's one more zero, yeah. 0.0001 over 4 factorial. So because the sign of z doesn't matter in this case, it's always going to be less than 1. So it's going to be less than this. So we know this error is going to be occur something plus minus this. So remember, this is the approximation value. Your sign of 0.1 is going to be less than 0.099833 minus 0.000004, or in this case, it's going to be 0.0099833 plus 0.00004. So that's going to be in between this value. You can use calculator to work it out. It's 5 zeros.
How did you get the 0.0001 over 4 factorial?
I plug in the remainder here.
Just use
I plug in this remainder, so it's f of f of 4 of z. What's f of 4 is z is the sine of z. Sine of z over 3 plus 1 factorial times the x value is going to be 0.1, but the center is at 0, so it's going to be 0.1 to the 4th power.
So you just, and then you just solve that to get the 0.0001.
Yeah.
Okay.
So basically, your error is going to be between here. So roughly, you'll end up to be 0.099833 less than sine of 0.1 less than 0.099837. So it's going to be between that plus that last term and minus the last term. The term after the last term, sorry, the 4th term. So it's going to be plus a little bit or subtract a little bit, just like last time.
Wait, shouldn't the left side be 0.00999793 and then the right side be 0.009873? I did it wrong.
Confusing as well. I think the left side should be 0.0998.
But there's two zeros.
833, yeah, 0.099833.
My math wrong. I lied. There's not two zeros. I put two zeros in front of it.
So what are they trying to say? Now, I remember this because I was watching Blue Pen and Red Pen went over some question like this, and he said to the audience, he said he didn't know how to do it in high school either. So, and he's a pretty big deal. So basically just adding the last term and then subtracting the last term. But not the last term. The term following the next term. The term following the last term. Because that term is going to be smaller than the last term. Does that make sense?
Yes.
Like, I'm going to rewind this again. Like, if you have, let's just say, if I approximate this 3 terms, right? Your error is going to be plus this or minus this. It's going to be plus this or minus this. Does that make sense?
Yeah.
Because this one's going to be smaller than prior term. That's the only thing what I'm saying. And that's it. We're done with Taylor and Maclaurin. Okay, so let's review everything in this chapter. In this chapter, what do you have to be able to do? You have to be able to start by understand all the tests, right? What are the first tests that we try to learn? So it's n term, divergent test. That's a test to see. That's the test to see if it's a divergent just by using limit and approach infinity. And if it equal to some number, then that automatically is divergent, right? And then after that, what do we learn? What? We didn't go to integral. We learned the next 2 thing is the telescoping. Series. And there's a geometric series. Okay, so we learned the telescope. Remember how to do telescope? You might need to do decompositions first, and you need to look at a pattern, see if it's going. Okay, so telescoping. So usually something to do with partial fractions, yes.
Nice.
And then you look for the pattern. Then geometric, then you have to see that pattern is times something. Now you have to find a common ratio, right? Usually find common ratio if you see it. Then you can do A1 over 1 minus R, right? So that's geometric. The next thing we learned the integral test. Yeah. So integral test, it has to be CPD. What does CPD stand for?
Decreasing.
Decreasing. It has to be following those conditions. Usually has something to do with arc sine or natural log of x. And the integral test, there's something that's super, my favorite test of all time, which is called P-series. Because that's so easy. Oh, by the way, if the R has to be less than 1, right? In order to be convergent. And this is the P has to be greater than 1 to be convergent. So my favorite series test is P-series. My least favorite is going to be comparison and limit comparison.
You know, limit comparison sucks.
Yeah, I actually didn't test you limit comparison.
You did it, and I really seriously thank you for that.
Yeah. So limit test and limit comparison and comparison. So compare, you just have to compare it with the P-series, compare the geometric and see what happened. So keep that last test and make sure you understand how to do all the detail. Limit comparison usually have multiple terms. And this usually one term.
What does that mean?
What does that mean?
What do you mean one term with multiple?
So that if you have just says direct comparison test, if you have direct comparison test, let's say for example that if you have just 1 over 2 plus square root n, like this is comparison because you compare over 1 over square root n. But that addition, that's just one term, you compare to that one term. Now for limit comparison test, it's more like this. If you have square root n over n squared plus 1, and if you have summation of n equal to 1 of infinity, so in this case you have multiple, you have the top and bottom situation here. You cannot just compare to 1 over n squared, because this one is going to be square root n over n squared plus 1, so you got additional term. Or something like this, summation. I'm just going to show you the example of n to the 2 to the n over 4 to the n to the third plus 1. Now, if you don't understand limit comparison test or direct comparison test, it's not end of the world. Now, what is the end of the world that you really need to know is the ratio test, right?
Yep.
But the next thing we also turn into alternating series. So alternating series, it has two conditions. What are those two conditions? Limit n approach infinity of a to the n must equal to 0. It must be alternating. If it's alternating and reach 0 and the a to the n plus 1 is less than a to the n, so if you have those two conditions, you're automatically using alternating and it's going to be convergent. Am I going too fast? So this is a review of all the things. Now, alternative series also has the remainder situations. The remainder situation that you have to worry about in term of approximation. And this one is going to be same thing, s minus s to the n is equal to r to the n. And you only worry about the n plus 1 term. So just plug in n plus 1 and see what happens. Alternate series also have two types that you have to worry about. It's are they absolute convergent or conditional convergent? Do you guys remember that? That's on your last test. So what are you gonna do? You're gonna do absolute value, and then you see if that's convergent or divergent after you do absolute value. If it's divergent, then you're gonna say that's conditional, right? So those are the two things that you have to see. So alternative series, you have something like, or it doesn't have to be alternative series, could be like sine of x over something. So you have to understand those. So here you have to think about the two situation. You got absolute convergent and you got conditional convergent. And go look at your last test. I give you two prime example, and that last test is the one that you have to worry about. Now, my favorite thing is ratio test. Why is ratio test my favorite thing?
It's universal. You can work on nearly every single one.
Well, not only that.
Yeah.
A P-series is the easy one, right? The hard one is going to be a ratio test. But why ratio test is important? Because lead to something else.
I don't know, it's just satisfying for me that everything cancels out.
No,
Oh, it leads to the second thing we do.
it's lead to what? Interval of convergence, right? Then also make sure you had to test the endpoints. So sometimes I will ask you, says, hey, can you find out interval convergence? Can you find the center? Can you find the radius? So the ratio test is the best test for that. So the most common test question, it's going to come up from the ratio test. Because ratio test is going to require says, so the way they're not going to tell you says, use a ratio test. They will say, hey, can you find interval convergence? And then at the endpoint, you had to either use P-series or alternative series or other things. So at endpoint, you have to do all that. But right now, the ratio test is the best thing to go to. The most popular test question is going to come up on the ratio test because they're not going to ask you to do ratio tests. They're going to ask you to find interval of convergence. And lastly, Taylor and Maclaurin. Maclaurin is centered at 0. This one's centered at where? At C, right? And I'll just write down Taylor so that way you can know. The Taylor just gonna be what's the best way to put Taylor? So Pn of x is equal to f of c. I'm just gonna write out the expanding form, and this is a Taylor. So f c of x minus c plus f double prime of c over 2 factorial x minus c to the second dot 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 dot. Keep on going. Is using the same pattern. The only thing difference with Maclaurin is what? C is 0. So it's going to be f of 0 plus f prime of 0 x plus f double prime of 0 over 2 factorial x to the 2. And there is lastly remainder. So today I'm going to give you a review sheet of everything. Review questions for the homework. And that's all AP exam style questions. So not additional harder things. It's all multiple choice. An answer we can talk about on a talking period. Wait, which block? Oh, we block impaired next week.
Yeah. Actually, I think it's Wednesday, Thursday, or Friday.
Yeah.
Thank you.
The block period is on Friday.
So we don't see.
What's up?
It's on Monday.
There's no letters here, Stu? Oh, it's gotta do double S. Double S. Yeah. It's.
Not ready.
I know it's double S. It might even be triple S.
Oh, no, are you talking about the drug test? It was really bad.
Oh, yeah, we'll come up with drug test.
A bunch of tactics stuff.
Okay.
I don't know what this X mark.
What's a
it?
cabinet? The what?
Mark,
Oh, that was on
Yeah, it's like